Hello everyone, welcome back to yet another video in the linked list series. In this video, we are going to solve the problem reversing a linked list. Now, this is a very important problem because it was asked to me in my PayPal interview as well. And definitely we are going to discuss about my interview experiences in some other video, but for now, let's focus on this problem. As usual, I'm going to write code in C++ and Java, but for this problem, we're also going to try to implement it both ways, using recursion plus using an iterative way. So, hang on tight and let's get started. So welcome back. Let's come back to the problem reversing a linked list. So let's suppose we have a linked list. Right? We'll take a linked list made of 3 nodes. Now, if you don't know what node and linked list is, you are welcome to watch my previous video where we even implement a linked list. So let's continue. We have these links, right? And in this problem, we are asked to reverse the linked list. By reversing a linked list, what do we mean? We mean that our final structure should look something like this: 3, 2, 1, right? Or better, I can write it as, consider this directly like this here. We'll have 1, 2, 3, and this becomes our head now, like this, right? Correct? If we are to reverse it, our head should become 3, and all the way the end element becomes 1, and 1 points, the next of 1 is null. So let's see what are the things we need to track, in order to be able to reverse this linked list. So what I'm going to do is I'm going to discuss the basic approach, and then we are going to understand how we can do this in an iterative way, and next we're going to understand how we can solve it using recursion. Recursion requires a little bit more understanding. Don't worry, we'll focus on it obviously. So coming with this, now we have, let's say, what are things I have to track about, right? At any given point, suppose I am here, right? I'm at 1, I'm starting at 1 and I have to reverse it. So I'm here. At any given point, I have to keep track of, let's, just, let me just erase this so that, oops, sorry. Yeah. Let's just quickly erase this. Okay. Yeah, we're good. So at any given time, suppose I'm at 1, what all things I need to keep track of? Let me just put do not disturb. Yeah, fine. So at any given time, suppose we are at any node. Let's say we are starting from 1, right? So we are at 1. We need to set one thing. We need to first set what will be the previous value of 1, right? And after, as I showed, after reversing the list, the previous value of 1 should become null. So I think we should start with the initial value of previous, null, right? And we can say, and my current, I'll keep track of my current as well, right? Which is the given head to me right now, right? Then what I also need to track of, before I change the value of next. I know, right? Current, see, in the end list, current next should become null, right? So before I change the next value of current, I need to save that as well to move on further in this list, right? I do not want to set current dot next is equal to previous. So basically 1 dot next becomes null, and then I'm lost in the list. I just cannot go to 2 and 3, right? So we need to save that reference as well. So we'll store it in a variable. Let's call it as next. So next will be current dot next, right? And now what we can do is, with all this information that we have, what we can do is we can then start to go on, and we can say that, we have our next value, which is current dot next. What I'll do is then current dot next is equal to previous, right? We already have our next saved somewhere. So we'll say current dot next is equal to previous, and I'll do this, and then I'll just move ahead. So now my previous becomes my current node, and my current node becomes the next node, right? These operations. We do all this unless we have nothing left, which means our current node on which we are is not, it's null. So we do this until our current is not null, right? Understood? Let's go through it once more to understand it better. I'll start again. So we have, you can skip to the next portion if you don't want, and if you don't want to go with this revision again. So but for everyone else, here it is. So we're discussing it again. So suppose we had a given linked list 1 2 3. This is our input. In the final output that we have and we want is 1 2, right? Reversing a linked list is simply reversing all the links, basically. Cool. So now with this given, at any given time, suppose I'm at 1 right now, right? And I have to start from 1, reverse this link, go to 2, reverse this link, go to 3, and return this as the head now, right? So let's see. Let's dry run our code, okay? Whatever we discussed it. But first, let's try to understand the algorithm. What we have here is at any given moment, I need to keep track of what's going to be the previous value of my current node and what's going on to be the next value. Because once I set the next value to previous value of my current node, I need a way to keep track of what was the original next value so that we can traverse forward in the list and do this reversal at the same time, right? So I'll say at first, what should be the previous value of 1? In the output list, it's null, right? So I will start with previous is equal to null, okay? Then again, we go, then again we have previous is equal to null, and then we have current, which is already pointing to, which is already our head, right? And next value, right? It's basically the next value of our current node, which will be current dot next, right? Then look carefully. What we do is at the current node, suppose we're at 1, right? We'll set current. We want to set the next value of current as null because that's what's there in the output, right? Null. So current dot next, and in this case we set it to previous because previous is obviously null, right? We said do this, and then we move previous one step ahead, and then we move current one step ahead, which becomes next. Now this whole thing has to repeat unless we have nothing in current, right? And what will be our new head? Let's dry run and understand. So previous was null, current is head, next is current is head, which in this case is 1, and next is current dot next, which is 2. So current dot next becomes previous, so current dot next, so we already have 1 to null, right? And previous becomes current, so we already have, so let's write all this down. So we'll have, let's see all our variables. So we'll have, after this iteration, previous becomes current, so previous becomes 1, right? At 1 next is null, right? So now previous and current becomes next, so current is 2, and next becomes 3, right? It starts with the next iteration when we define next. So next is 3 now. Current dot next becomes previous. So previous was 1. So current dot next. Current is 2. So 2 next becomes 1. right? And once next was already null. So we have built our list here till now. And again the variables change, and we have, we'll have previous as 2, current as 3, and again the iteration starts with next is equal to null ho jayega. In this case next will become null, right? Because if current is 3, next is obviously null in the original linked list. If next is null, then the next statement that we execute is current dot next, which is 3 dot next becomes previous, which will lead to 3, 2, 1 and null, right? And then we have previous is equal to current, and current is equal to next. And what was next? Next is null, so current becomes null. We terminate, and what's the value of the latest head? It's stored in the variable previous, so we return the new head as previous. And that's how we do this reversal of linked list. I hope you understood this. We are going to code this same understanding in C++ and Java, and this will constitute our iterative way. So hang on for that. And after all this, we are going to discuss it in the recursive way as well. So looking forward to the next section. Alright, so welcome back to the implementation section. This section we are going to implement the iterative solution, and as I said, this question was asked to me in PayPal interview, so we are going to solve this on lead code, because we'll have a lot of test cases as well to test our problem if it's correct or not, right? So let's try to first implement in C++. So what all did I mention in the last section? What all did we need? We needed a previous, right, which is null. We need a current, okay, which is the given head. We also need a next, which will initialize inside the loop with our condition. What was our condition? While we don't have any nodes left, which means while current is not equal to null, and it's null ptr in C++, not, or it's capital NUL. I'm using null ptr. With this we have what did we do? We have next. Now initialize next as before modifying currents next. Current next, right? Now we can change currents next to previous, previous, and now we just move the pointers ahead. So previous becomes current, and current becomes the next one, right? And the answer was stored in previous because current becomes null. Right, let's test it out. Let's run code and see. Prev, right? So not using any short forms. Let's see. Address of overloaded function prev, again prev. Why am I writing prev? All right, let's go. So the basic test case is accepted. Let's submit the problem and see. All right, so it says accepted. Let's take a look. And yep, solved it. Cool. So now let's implement the same solution in Java as well. I'm going to remove my existing code. Yep, now let's try to solve this in Java. So again, the same things. What do we have? We have a list node, which is equal to list node previous, or I'll just call it prev because I don't want to make any mistakes now. List node current, which is equal to head, list node next, null for now, while current not equal to null. We are going to assign next to current dot next. Then we have prev we'll have current dot next is equal to previous, right? And then we move just ahead, so prev current and current equals next, and the answer is stored in previous, right? Let's run this out and see. All right, accepted for basic case. Let's run with all the test cases. Cool, accepted, 0 milliseconds. Wow, amazing. So that's how we implement the iterative version in C++ and Java. Hang on to the next section because we have a recursive solution as well, and you will need some understanding this for that. So let's go on to the next section, and I would require your attention over there. Alright, now in this section we are going to talk about the recursive solution for reversing a linked list, right? So I want your attention here, so let's try to understand. Again, I mean, in the iterative solution we had the track of previous, and we assigned the current node the previous value and just kept moving on, right? So here also we'll keep track of our previous value and current value, and next value we can get using recursion itself. How? Let's discuss. Let's suppose we have a function, right? We have a function which basically let's say takes two things. Let's call our function as reverse, right? Which takes two things. It takes the current node and the previous node, right? What we do here is, okay, current and the previous node, right? And let's say we have access, we are doing this somewhere where we also have the access to head. I'm assuming that we have a class structure, we have head access to it. If we don't have access to head, we will need to add head to the reverse function as well. So I mean, this problem will generally be asked to you with a given head. Given a head, return the reverse of a linked list. So either do it in an iterative way or in a recursive way. We are discussing the recursive way here. So I'm assuming that we have the access to head, right? So what we are going to do here is, so first of all, what we are going to do is we are going to recursively call the reverse function to reach the end, right? How do we do that? We call reverse by giving current dot, let's say, get next, and the previous as current, right? We do this, we do this, we do this. There will be one point when this becomes null, right? So this was our current value, and current becomes null. So now if current is null, then we are at which value? Suppose it was 1 2 3, we call with 1 comma null, and then we recursively call 2 comma 1, then we call 3 comma 2, and then we call null comma 3. So the head of the new linked list becomes the previous value in this case when we reach this base condition. So we say now head is the previous value because current is null. Previous is the last value we've reached. So we say that head is here. Let's return. Now, so I'll just write what I have said till now in a better way. So we'll have something like base condition if current is equal to null, then we say head is equal to previous, right? And then we return. Below we already had a recursive call, so we'll say reverse given we have cur dot next and current, right? So we traverse till the end, and now the important part comes here. Now let's see, let's use our visualization for this part. We have 1, we have 2, we have 3, right? Let's see, let's call it with, let's call our function as reverse head comma null because the previous value is null initially, right? I mean the previous for 1 should be null, right? So we call with head comma null. Okay, so now we start with this. So if we have now what we have is in the function we have current equal to null, which is not the case. So it will not go inside the if condition, it will call this reverse. So now reverse, let's call the reverse gets called with 1 comma null. Then if condition is not true, reverse gets called with 2 comma 1. Then reverse gets called with 3 comma 2, and then reverse gets called with null comma 3. Now we reach the if condition. So in the if condition, what are let's draw the call stack for now. Every recursive call goes into call stack. So we'll have 1 comma null here, then we'll have 2 comma 1 here, then we have 3 comma 2 here, then we get our null comma 3. We return something here, right? We return here. Now this pops out and we return out of here, and then we say head is equal to prev. So head for now is 3, right? So we have set our head as 3. Now this pops out, and this what is it, 3 comma 2 comes on the top, right? So the current was 3 and previous was 2. So what we do is current is 3, previous was 2. So we say current dot set next previous, which was 2 in this case. So 3's, this becomes 2. And it's all references here, right? Why? Because head and these things point to the same object, right? So we say the next becomes 2 here. Again, this gets popped out. Now we have this 2 comma 1. So now it makes 1. And again, this pops out and it goes to null. That's how we reverse it using recursion. So a full function implementation, a pseudocode kind of thing would look like. One sec, yeah. So it would look something like, let's say we have a function reverse. Again, I'm saying head is available to us. If not, we'll see it in the implementation. We'll try to solve this problem on lead code using recursion. Okay. So let's do reverse current node comma previous node. Okay. What it does is if current node is null, then we set head as the last node which was available to us was previous, and then we return the base condition for us. And as usual, we recur till the end. So in order to reach the end, we move to next and previous as current. Then while coming back, we just do current dot next is equal to previous. This simple implementation is the linked list reversal implementation using recursion. I'm just saying that we have the access of head here. I hope you understood it. It's very, very beautiful solution, and if you did not understand, you should go back and try to understand what's going on. It's a very, very beautiful solution. So head on to the next section to see the code implementation of this. All right, so now we are going to implement the recursive solution in C++. So let's see. Now, as discussed, we have a current and a previous and a head that can be modified, right? So let's write a helper function for that. Let me return head for the moment, and let's write void reverse list helper. Then we have list node current list node previous, and we have list node head passed via reference, right? So as discussed, if current is null, then our head becomes equal to previous. then we return, right? Otherwise what we do is we recurse, reverse list helper current next, current becomes the previous, and we already have a head, right? And then just we do current next is equal to previous, right, as discussed. Then we modify head, we just call this function here, reverse list helper head comma null ptr comma ampersand head, which basically passes the head via reference. So we're actually here also we need to use that so that we can modify it in this function, right? Let's run code and see. All right, this is accepted. Let's submit it. And there we go, it's accepted. See, so that's how, guys, that's how you implement it using recursion. Well, that was it for this video, guys. I hope you guys enjoyed the video, and if yes, do give it a thumbs up, and please subscribe to the channel if you're new here, and catch you guys in the next one. Till then, take care. Bye bye.